The device in your hand contains billions of invisible switches, each one smaller than a virus, built at the edge of what physics allows.
This is a semiconductor fab, one of the most advanced buildings ever constructed on Earth.
Entry requires full protective suits, not for the workers. For the chips, one dust particle can destroy a wafer worth millions. Inside, the air is 10,000 times cleaner than a hospital operating room. Every breath, every movement, controlled. It all begins here, with ordinary sand. Silicon dioxide, the second most abundant element on the planet. That sand is melted at over 1400 degrees Celsius, purified until it becomes the cleanest material humans have ever created. A single crystal seed is lowered into the melt, then slowly pulled upward, rotating, growing into a perfect silicon ingot nearly 2 meters tall. The result? A flawless cylinder of silicon. 9 nines pure, 99.9999999%. Diamond wire saws slice the ingot into wafers, each one thinner than a human fingernail. Each wafer is polished to atomic-level smoothness, a surface so flat it defies the limits of measurement. These wafers are the blank canvas. What happens next is where science becomes art. A light-sensitive chemical called photoresist is spun onto the wafer surface, coating it in a layer just atoms thick. This machine costs $200 million. It fires extreme ultraviolet light, the most precise light source ever engineered. The light passes through a mask, printing circuit patterns just 2 nanometers wide, 50,000 times thinner than a human hair. Plasma etching carves the pattern into the silicon, removing material with ion-level precision, layer by layer. Between each layer, gases are deposited at near atomic precision, building conducting pathways thinner than DNA strands. A single wafer now holds billions of transistors, each one a switch, toggling on and off billions of times per second. Every wafer is inspected, optical systems scanning for defects invisible to the naked eye. Automated scanners map every nanometer of the surface, hunting for flaws that no human eye could ever detect. Once complete, diamond saws dice the wafer into hundreds of individual chips, each one called a die. Robotic arms pick each die with vacuum precision, placing it onto its packaged substrate at speeds the human eye can barely follow. Gold wires thinner than silk thread are bonded between the die and its package, forming the electrical bridges that carry data at light speed. Black resin seals the chip, protecting those microscopic connections from heat, moisture, and physical shock for decades. The sealed chips move through curing ovens, the resin hardening under controlled heat into a shell tougher than most metals. Now comes the gauntlet. Every chip is tested, probe needles making thousands of simultaneous electrical contacts. Chips are pushed to extremes, from -40 to 150 degrees Celsius in seconds. Only the perfect survive. Chips that fail are marked and destroyed. In this industry, there is no second chance. Perfection is the only standard. Quality engineers analyze every failure, feeding data back into the process to push yields higher, batch after batch. The survivors, perfect, tested, certified, are loaded into anti-static trays, ready for the world. Every chip receives a unique identity, laser-etched serial numbers traceable back to the exact wafer, batch, and machine that created it. From the clean room to the warehouse, millions of chips staged for air freight to every corner of the planet. They travel by air, climate-controlled, carefully handled, because a temperature spike could compromise millions of dollars in silicon. Right now, thousands of flights are carrying microchips across oceans, the invisible supply chain that powers civilization. Into your laptops, your cars, medical scanners, satellites, every modern machine runs on these invisible engines. Soldered onto a circuit board, the chip becomes the brain, processing billions of instructions every single second. The fab never sleeps. 24 hours a day, 7 days a week, billions of chips born from sand and light. Smaller than a fingernail, more complex than anything nature has ever produced. The microchip, humanity's greatest invention. From a grain of sand on a beach to the processor powering the future. This is the miracle no one sees. This is the microchip.